Good afternoon, ladies and gentlemen. This work concerned about the interaction of conical monolithic thin-walled reinforced concrete shell with the soil of the foundation. Conical monolith thin-walled reinforced concrete blocks. It's the shells that can be used as foundation for frame structures and buildings with load-bearing walls. They are made of concrete in spherical forms and have a metal frame. Their geometric shape is a truncated cone. Shells are immersed in the supporting soil base with the help of dynamic or static loading. Additional soil base compaction occurs due to interaction with the conical or the surface of the shells. The work aims to develop the theoretical foundation for modeling, mathematical description, and the possibility of optimization for the process of thinking monolithic thin-walled spatial reinforced concrete shells that model foundations for low-rise technological of residential facilities. Methods of modeling the progress of immersion of the shell into the ground are shown on this slide. It is proposed to apply simple models that could reflect only the main properties of the system, and large numbers of temporary features would be taken into account in a generalized way or through the values of calculated indicators. Such simplest soil models for the analysis of the hammerhead shell soil system are plastic and elastically elastic. Dynamic models of the hammerhead shell soil system are shown on this slide. And dynamic models of the hammerhead shell soil system are shown also on this slide. Here presented the elastic plastic model with attached soil mass, elastic viscosic plastic model with attached soil mass. It's C and D figures. The dynamic models of the hammerhead shell soil system is presented as follows. The elastic shell, which is in the soil, is stuck with a hard, undeformed hammer through the elastic head. Under the influence of the impact, the shell acquires a reserve of kinetic energy, which is spent on overcoming soil resistance with each impact. The shell sinks, initially elastically deforming the soil by the amount C, and then the plate moves into the soil by the amount of initial failure E. Elastic deformations are restored after each impact. Each blow is considered as a single one, isolated from others, which means that before each subsequent impact, the shell, hammer, and the soil are at rest. Hammerhead shell soil system shown on this slide. For the development of mathematical models of the process of immersion in the ground, base of conical reinforced concrete shell, a calculation scheme is proposed on the figure shown on the slide. A, it's a real system. B, it's calculation scheme. Here the mathematical models of this process is a system of nonlinear differential equation consisting of the equations of the hammerhead and shell soil subsystems, which must be solved jointly. The mathematical model of hammerhead's shell soil is a system of nonlinear differential equations of the second order. Order is shown here. Workflow parameters included in the math model also presented on this slide. factors that have the greatest influence of the immersion process. First, its ultimate resistance of the shell on the soil. Second, lifting height of the impact part. Third, the ratio of the mass of the striking part to the mass of the submerged shell. Fourth, the thickness of the elastic gasket in the headrest. Wood or conveyor rubber can be used as a cushioning material in the headrest. The soil's stiffness depends on the value of the lateral resistance, so that the elastic failure does not exceed 1 cm. This value of elastic failure is most often encountered in practice. Calculation of the computer on a computer were carried out for a hammer with a striking part weighing 500 kilograms. Mathematical planning of the experiment was used to organize calculation on a computer. The four-factor Hartley-Cohen plan was adopted. In order to obtain analytical dependencies between the parameters of the studied system, a correlation analysis of the obtained data was carried out. The regression equations of the type were used for the analysis. Here is these equations. Oscillatory progressing system, hammer, head, soil, shell soil system. Coimpacts in the hammerhead shell base system are characterized by the force that appear at the contacts of the elements that are in direct contact during the impact. On the figure 5a and b and c graphs of changes in time of these forces calculated with the same initial data for some time at a level of 0.03 seconds after the first contact of the hammer with the head are given. The impulse of impact forces is characterized by several peaks and has a complex damping character. The contact of the shocking part with the head is irregular. Thus, for a period of 0.6 seconds, 11 coimpacts occurred at the hammerhead contact and 10 at the head shell contact. Force section on the contacts of colliding bodies are shown on this slide. This graphs indicates this. A it's hammerhead, B it's head shell, and C it's the frontal resistance of the soil. These dependencies are shown here. The correlation dependencies for the impact force are presented here. And the last one slide, it's conclusions. First conclusion: the theoretical foundations for modeling, mathematical description, and the possibility of optimization of the process of immersion of monolithic thin-walled special reinforced concrete shell in the soil environment have been developed. Second, evaluating the possibility of using complex model for practical calculation, it should be started that at the moment where it is not enough experimental data for a justified assignment of the numerical values of many indicators characterizing these models. Third, the following factors significantly influence the failure of the shell: hammer, lifting height, soil resistance, and the ratio of hammer and shell masses. The effect of shock absorbing elements is insignificant. Fourth, the most significant influence of the magnitude of the contact forces in the zone of hammer shell has such the height of the fall of the hammer and the stiffness of the elastic gasket, the influence of the ratio of masses of the hammer and the shell, as well as the value of the soil resistance, is manifested to a much lesser extent. Thank you very much for your attention.